Hello and welcome to IT Made It Easy. In today's episode, we are diving into a topic that's been gaining a lot of attention in the world of networking: SD-WAN, or Software Defined Wide Area Networks. You might be wondering what exactly is a software defined wide area network and why is it so important? Well, let's start by saying that SD-WAN is the revolutionizing way of business connect, manage, and secure networks, especially with the rise of cloud computing and remote work. It's all about making networks smarter, more flexible, and easier to manage, especially without the heavy cost or complexities of traditional networking solutions. So stay with me as we break down this technology in simple terms and explore how SD-WAN is transforming the future of networking. Let's take a look on this diagram and let's see what's going on here. Basically, this layout is a typical um, middle-sized business network with the headquarters, and we have three remote sites: Houston, Los Angeles, and the third one could be, let's say, New York or a campus. Okay, let's take a look at the top of the diagram where we have the vSmart, vManage, and vBond. Let's start with these three components, and these three components are also called the controllers. These are the controllers of the SD-WAN. So when someone is talking about controllers, he refers he refers into these three components: vSmart, vManage, and vBond. What exactly these components or these controllers are? Let's start with the vBond. The vBond controller is like the security guard of the SD-WAN network. It makes sure that all devices, whether it's a device in Houston, LA, or New York, or any other parts of the network, are who they say they are. When a new site or a device tries to connect or joins our network, the vBond authenticates this device. And after the authentication has taken place, then this device is allowed into the network. It also helps establish secure connections between all the controllers and devices. So for example, when I install a new network device, a router, into my Houston office, so the first thing this router has to do, and I'm talking about that router right here in Houston, has to talk to the vBond. The vBond will authenticate that router in order to confirm that this router is who he says he is. Then that router will participate into this network topology. So through the vBond, that router in Houston will be able to talk later on to vManage and to vSmart. But let's see what the second controller does, the vManage. The vManage is the centralized screen, is the control room of my SD-WAN network. This is where the network administrator, through this device right here, observes and monitors every activity into this network. From the vManage, which acts as a central control center for the entire network. The network admins can configure network, set up rules, we'll talk about rules later on, like security policies or routing preferences, and monitor how everything is performing. If there is an issue, let's say a slowdown in the Los Angeles office, right here, if there's an issue at this office, the admin can quickly diagnose the problem and make changes to improve performance, and all of this through a simple dashboard, the vManage. So the vManage, think of it as the graphical user's interface. Then we have the third controller, which is the vSmart. The vSmart controller does something smart. As the operates as a traffic manager of the SD WAN network. It's responsible for deciding the best route for data to travel between sites. For example, if Houston wants to send data to the Los Angeles office, the vSmart controller decides whether it should go through the fastest route, maybe via the internet, or the most secure route, perhaps a private connection that they have here. Might be a so-called MPLS connection. The vSmart controller ensures that everything runs smoothly by enforcing security policies and traffic rules that the administrator has set up. So in order to remember the role of each one of the controllers, the names actually will give away the role. So the vBond controller basically creates a bond, a relationship between the routers or any other device on the network and the SD-WAN control center. So if the newly discovered router does not pass the vBond authentication, he will not be able to participate to the SD-WAN network. So that's what the vBond does. That's the bonding. And don't worry right now about what kind of devices these controllers are, because we're going to further look deeper into the installation and configuration and the nature of these controllers. So the second controller we talk about is the vManage. This is how the administrator manages the entire network, creates routes, and enforces policies. There are many ways for one side to connect to the other side, and that depends on the infrastructure that we have. For example, between Houston and Los Angeles, we might have a private MPLS connection, or there might be no dedicated connection between these two sides. Houston might be talking to the public internet, and so does LA. So there is no direct connection between Houston and LA. So the vManage will have to find a way to make these two sides communicate as needed. And finally, we talk about the vSmart, which is a traffic manager. The vSmart actually decides the best route for data to travel between sites, and if there is a direct tunnel, if you like, or a direct highway between Houston and Los Angeles, vSmart will decide if it's proper for the information to travel through that highway between Houston and Los Angeles or take another route. So imagine vSmart is smart because it acts like the GPS of traffic. So it finds the most optimum way, the fastest route for traffic to travel between one site and to another. So this is an introduction to the controllers and how exactly do they participate, the primary role of each controller into the SD-WAN network. So for now, let's remember SD-WAN network is a new type of network that lately tends to replace the traditional networks. We haven't really talked a lot about the benefits, but we talked about the components, which are the vSmart, the vManage, and the vBond controllers. So this is the word we use for SD-WAN controllers. One last thing before we go. How does every remote office, for example, Houston, Los Angeles, and a third location, uh, communicate with the outside world? Well, they do communicate via these devices that we call routers. In this case, they're called V-Edge routers. It stands for virtual edge routers because they stand at the very edge of this topology of this remote site. So that router is the gateway for traffic in and out Houston office. So if a user from Houston office wants to send data or surf the internet, that request has to go through that router, and vice versa when answer or data is coming from the internet to the Houston office, it goes through the router. Same for this Los Angeles site and the same for this third remote office. So this network diagram represents actually a network of a, we would say, middle-sized business. It's a corporation that has its headquarters somewhere. For example, could be New York. These are the headquarters right here. And also, as you can see, the headquarters have a router in order to communicate and send and receive information to and from the outside world. They have this gateway, if you like. And also, the company is quite big and has remote facilities, and these remote facilities must communicate with each other and must communicate with the headquarters. And this is where the SD-WAN network come into place. This is a wide area network. It's wide because it covers a wide geographical area, as you can see. The network covers several states of the continental United States, or we might have offices overseas. So this is a basic introduction into the SD-WAN network. And on the next episode, we're going to look a little bit deeper on the connection and how these controllers actually talk to each other. I hope you found this video informative, and feel free to ask questions on or leave any comments. Thank you for watching.